Okay, this is the so-called chopper circuit. So it's lab 20, part 6.2. And I've circled the DG403 pin numbers. So the idea here is that we have two different signal sources. I'm going to use channel 1 of the analog discovery function generator, that's yellow, for this first signal source. I'm going to use channel 2, that's yellow with a white stripe, of the function generator for this signal source. So this one is going to be a 100 hertz sine wave, and this one will turn out to be a 99.9 hertz triangle wave. And the reason why it's kind of neat to make them just 0.1 hertz apart is you get kind of a neat beat frequency. And then this is supposed to be a toggling back and forth signal. I made this a 2 kilohertz toggling logic signal using one of the digital output pins of the analog discovery board. So I'll show you that in a moment. This is grounded because it's an unused CMOS logic input. You always ground those or put some fixed voltage on them. And then these two pins are the outputs of the two halves of this analog switch. They're tied together because the scope is going to be looking alternately at 1, 2, 1, 2, 1, 2, 1, 2. So the scope is going to be toggling back and forth because when one of these is closed, the other one is open. And then when this one is closed, this one is open. So here is the circuit. So in this case, there's not much to it. It's just a DG403 with some wires. So there are the usual four power connections. I'm just using plus and minus 5. This is plus 5, ground, minus 5. And this is the spare CMOS logic input that we grounded. And then we're using this to toggle back and forth between the two signal sources. And then this and this are our two outputs, which are wired to each other. This is one input. This is the other input. So then this is how it's wired up on the breadboard. Yellow is the first signal source from the scope. Orange is the first channel of the scope to watch what's happening on yellow. And actually, you'll see I have that channel turned off, but it's my trigger source. Then blue is scope channel 2. It is looking at the output of this circuit, which is, you can take your pick of pin 1 or pin 3 down here, which are wired to each other. Yellow with a white stripe is the second signal source channel. So that is wired to pin 4 down here. So 1 and 3 are wired together. 1 goes to scope channel 2. Pin 4 goes to signal generator channel 2. Pin 16 goes both to scope channel 1 and to signal source channel 1. Now this kind of salmon colored wire is number 0. It's logic output number 0 of the analog discovery board. So I'll show you how I did that. And again, the only power here is plus and minus 5 and ground from the analog discovery board. So I have signal source 1 is a 100 hertz sine wave, amplitude 3 volts, offset 0. Signal source 2 is a 99.9 hertz triangle wave, amplitude 3 volts, offset 0. And then this is a little tricky. You go over to patterns, it's like logic patterns. And I chose pin digital input output 0. It's an output. I'm not sure what PP means, but OD would be like open drain, I think, and OS would be like open. Open drain makes sense. I'm not sure what OS means actually. So anyway, it seems like it's PP. I haven't looked up what these things mean exactly. Then we're going to make it a clock output, and 2 kilohertz seem to give me good results. So it's like basically it's going to toggle back and forth between 0 and 5 volts at a frequency of 2 kilohertz. And remember, I turned my power supplies on, and then I go back to scope. This is kind of a pretty cool effect. So I have channel 1 looking at the sine wave input, which is connected to pin 16 of the DG403, and I'm triggering on that so I get a nice consistent play out of the sine wave, but then I don't display it. And you can see what the DG403 is doing is at a frequency of 2 kilohertz, it's toggling back and forth between one signal and the other. So you see in waveform 1, waveform 2, waveform 1, waveform 2, waveform 1, waveform 2, back and forth. So it's essentially showing you the 2 waveforms at the same time, and you can see how it toggles back and forth between them. So I think that's kind of, you can just single trigger if you want to hold the display for a minute. I don't know, I think that's kind of a neat effect. And then, you know, if you're interested in like the physics of beats, you can go back to waveform generator, and I could make this 99.8 hertz instead, and instead of passing each other every 10 seconds, now they'll pass each other every 5 seconds. That's kind of fun. Or I could make it 99.5 hertz, and we'll see them pass each other every 2 seconds. That's kind of fun. Here, and let's go back to the slow version again. So we'll go back and do 99.9 hertz. Okay, and then here, let me change the toggle back and forth frequency to, let's make it 5 kilohertz. I've never tried this. Yeah, okay, so it looks, you know, it's toggling back and forth more often, so it's like you get a higher resolution version of this superposition of 2 waveforms. And if you make it too low a frequency, then it's kind of a poor result. So that's, yeah, that's okay. If you make it any slower than that, it looks pretty poor. Yeah, see, that's a little harder to see. But, you know, you go to, yeah, even 5 kilohertz, that's kind of cool. Yeah, that's a pretty neat effect, I think. All right, so I think this was a success. So this was the chopper circuit. And effectively, this is how old-fashioned oscilloscopes used to turn one oscilloscope channel into 2. They would toggle back and forth. Actually, there are 2 ways they did it. One is they would draw a whole screen full with one input, and then draw a whole screen full with the other input, back and forth, back and forth. But that only works with fast inputs. With slow inputs, they would do back and forth in the middle of one sweep of the screen, looking at one waveform, then the other, one waveform, then the other. Okay, neat, ha.